Okay, so this is a video about section 4.5. This section is on the easy side. Really, the only questions I put on the online homework about this were slant asymptotes. So, we've talked about vertical asymptotes and horizontal asymptotes, which are just lines that are either vertical or horizontal, depending what type of asymptote we're talking about. And it's a line that is approached by the graph. So what we're going to talk about now is a slant asymptote, which is like the same thing, except it doesn't have to be vertical or horizontal anymore. It can be any line. So here's a picture of a line, and then I drew a curve, and it looks like if I move farther and farther to the right, the curve and the line are getting really, really close to each other. So mathematically, we talk about this situation when y equals something that looks like a line, so I wrote mx plus b, plus something else, g of x. If this something else, if that goes to 0 as x goes to infinity, or as x goes to negative infinity, then we call this a slant asymptote. Because basically what's happening is, in this picture, if I do the limit as x goes to positive infinity, then it looks like this curve is matching up this line. So in this picture, it's this situation. If I move farther to the left, it doesn't really look like the curve is very close to the line. That would be, if this was happening as I move to the left, like if this curve comes back down and approaches the line as I move farther to the left, that would be this situation. So yeah, this is basically just y equals the formula for a line plus a little bit extra that is going to 0. And that would be why the curve looks like it's very close to the line, either as I move to the right, or as I move to the left, or both. But, so, really, the only questions you're going to get asked on the online homework are going to be to find a slant asymptote, and it's going to look something like this, and basically the way you do this is just long division. So, it may have been a while since you did anything like this, but, so what do we do? How do I do this division? I look at my first thing here and my first thing here, and then I say, what would I have to multiply this by to get this? And the answer to that question is 3x. That's what I would have to multiply this by to get this. Every time I write a number up here, I'm going to multiply this all the way through, and I'm going to write the result underneath. So this times x squared is that. This times 3x would be 9x squared. This times this would be negative 3x. And then I'm going to subtract that from what's above. And I put parentheses around here because I want to remember that this subtraction distributes to everything. Okay, whenever you do this, the first thing should just go away. It should always just go away. I see 3x cubed minus 3x cubed. Good, that's gone. Other than that, I have a minus 2x squared minus a 9x squared. This is where I have to remember this minus. So that's negative 11x squared. And then I have a plus x plus 3x, so 4x. And I'll just carry the 7 down. Okay. Now, I know that I'm done when the degree of this is smaller than the degree of this. I'm not done yet because the degree of this is 2 and the degree of this is 2. I'm only done when this degree is smaller. So I have one more step to go. I'm going to do the same thing. Now I'm going to say, what would I have to multiply this by to get this? And the answer to that question is -11, which is what I write up there. And now I do the same thing again. I just wrote a number up here. That means I'm going to take that number and multiply it through everything here. That's -11x squared minus 33x plus 11. I subtract all of that from what's above. The first thing should just go away. I have -11x plus 11x, so that goes away. Other than that, I have a 4x plus 33x, so 37x. And I've got a -7 minus 11, so -18. Okay, now I'm done because the degree of this is 1, which is smaller than the degree of this, which is 2. So, what is my answer? This is called the remainder. So the result of dividing this by this is what I got up here plus the remainder over the original thing that was on the bottom. It's this same x squared plus 3x minus 1. Okay. So what did we just do? I just did long division. We started with this, and then I did long division, and I got this. 3x minus 11 plus 37x minus 18 over x squared plus 3x minus 1. And guess what? This goes to 0 as x goes to infinity. Right. The easiest way to see this is to just say that the degree on top is smaller than the degree on bottom. We've done a lot of limits of polynomials like this. We know that the only thing that matters is the biggest power of x here and the biggest power of x here. I could cancel an x and I would just have an x in the bottom, which means as x goes to infinity, this is all going to 0. The same would be true, by the way, the same would be true as x goes to negative infinity as well. But in any case, what we did is we wrote it in this form. I got something that looks like a line. Here's the part that looks like a line, 3x minus 11. And then here's the extra part that's going to 0 as x goes to infinity. So, in conclusion, the slant asymptote is just 3x minus 11. So that's how you do these, and on the online homework they're all essentially the same. It's all just a polynomial over another polynomial, and all you have to do is long division. So the biggest thing for you to, the biggest skill for you to have for this section is long division. I'm sure you've all done this one way or another before, but this is the type of thing that people forget, so you'll have to remember it again.